Welcome back, everyone. Anthony Goddard will tell us about monitoring in an automated world. A lot of scaling and cluster cloud things to show us. Have fun and give him a warm welcome.
Good morning, everyone, and thank you very much for coming along to this. So today I'm going to be talking about monitoring challenges in a world of automation. So my name is Anthony. I'm the Vice President of Operations for Sensu Inc. If you want to follow me on Twitter, mostly I tweet about like people that do crazy adventures around the world. It's kind of like a hobby thing of mine. But if you want to follow an awesome open source monitoring company, then you can also follow @Sensu. I'm kind of guessing everyone here is into open source monitoring. So about Sensu. Sensu is an open core monitoring framework. It was originally released in 2011, and it was written by a guy called Sean Porter. And when he built it, it was to replace a Nagios cluster that they had monitoring their infrastructure, and the biggest issue they were having at the time was false positive alerting. So they were scaling their nodes up and down quite a lot and finding they were getting a lot of alerts for nodes that didn't exist any longer. And that's going to be the primary basis for the Sensu talk that I'm doing today. We launched a Sensu Enterprise offering in 2015. And then earlier this year, in January, we started Sensu Inc. So we originally were a consulting firm that consulted a lot with Sensu, and then we pivoted to do 100% Sensu. So this year we've grown to 20 staff. We've just finished hiring for this year, but pretty early in the new year we're going to start hiring more engineers and growing a bit more. So Sensu itself is we call it a cloud-native monitoring framework. So it's a monitoring tool that's designed to work specifically with infrastructure that you are dynamically scaling very fast, ephemeral nodes that may only exist for a few minutes, for example. And we also refer to it as the monitoring router. So it's a very unopinionated piece of software. The idea is that Sensu agents that sit on nodes or external systems that are sending data into Sensu, they all just throw the data at Sensu, and then Sensu can take data from, let's say, metrics data from a node and choose where to put it. It can take service check data from a node and choose to put it somewhere different. And then we have corresponding routing on notifications as well. So we can say, this team over here are the ones that care about these particular servers when they go down, and they like to be notified by Slack instead of pages, for example. So conceptually, we think about it much like a router where there's a lot of data coming in, there's processing being done and decisions, logic being made, and then the output being storing events for metrics or notifications. So it's full stack monitoring everywhere from the base of your infrastructure all the way through to your application code. So in your application code, you can instrument your code to emit events or emit metrics directly to Sensu, and then have Sensu take care of routing that data. Like I mentioned, it's designed for automation. It's cross-platform, so we have Linux, Windows, BSD, AX, Solaris, and macOS. I think we even have a Raspberry Pi package, but it's unofficial. So quite a lot of support. And if you want to learn more about Sensu itself, you can hit up the website sensuapp.org. So our mission statement as a company is to obviate the need to rebuild custom monitoring solutions. So we really think that the only true path to reinventing, or to stop reinventing monitoring, is to have open source software. And so we have a very firm belief in Sensu as an open source product, with the enterprise offering some additional services specifically to enterprises. And as an open source monitoring company, we're super happy to be here at OSMC. But this talk is not about Sensu. So we organize a bunch of conferences ourselves. Different folks on the team have been involved in DevOps Days and Monitorama and Automicon. And so we know that people don't really like going to conferences just to talk about vendor stuff. So we're going to keep this as neutral as we can and talk about some of the challenges that we find in monitoring for ephemeral environments. So Monitoring ephemeral systems, we're going to review the what we see as the cloud-native monitoring requirements, and we see them as automated discovery, automated monitoring, and then automated decommissioning. And the last one is probably the most exciting, I think, of the three. We're also going to go over a couple of cloud-native monitoring anti-patterns, and we're going to do a live demo, which I have tethered to Stefan's phone, so it should work. What could go wrong? We're ready to go. Traditionally, I'm not going to retell the DevOps story, but traditionally there's been IT operations and developers used to sit on these two sides of the silo, and there was always competing interests of each. One wanted to move fast, the other one wanted to keep things stable. And obviously, as things like DevOps adoption and cloud adoption has increased, we have these situations where developers are increasingly able to perform operation tasks, which means we have servers that are just appearing out of nowhere or appearing for only short periods of time, and there's multiple parties in a company who are able to provision those servers. So gone are the days of the developers request a server, you have to provision the hardware and rack it up, and you have time to do something like write a complicated monitoring config. Now a developer could just spin up a node without operations knowing, but operations is still going to be responsible for making sure that node doesn't crash or doesn't go down. So cloud platforms and automation systems cause changes in the infrastructure, and that increases the complexity of the monitoring. New systems that are created need to be discovered quickly and easily and monitored. And monitoring needs to know the difference now between something that is down and something that has simply been decommissioned. Our infrastructure is becoming increasingly more automated and ephemeral, so we should expect that our monitoring systems are able to keep up pace. So basically, have any changes that are made in the infrastructure need to be visible as quickly as the infrastructure is changing. So again, the three major things: automated discovery, automated monitoring, and automated decommissioning. These are what we see as cloud-native monitoring requirements. It's not an exhaustive list, obviously, of what we think monitoring should be, but it's the three things that we think are the most important when it comes to monitoring ephemeral infrastructure. So we'll step through each of those. Automated discovery first. So any new system should be automatically discovered. So in the same way that a new system is automatically provisioned, there shouldn't be any process that's required to manually make changes in order to monitor the system as it comes online. Some of the cool things that the cloud gives us is the ability to provision, have provisioning events that do creation of instances and replacement of instances, automated scaling of instances, so auto-scaling groups, for example. So your cloud provider can just go from 2 instances of a web server to 100 instances and back down to 2 instances. And external systems are able to use APIs to your infrastructure to request changes that be made. So that may be changes with networking, it may be changes with spinning up instances. But these are all really cool things about the cloud, and they're things that make monitoring a challenge. So some of the anti-patterns for monitoring in this case would be polling-based discovery. So we don't want to go and look for things. We want, when the things are created, we need them to make the system aware of their existence. Any sort of old school discovery that needs, or that doesn't allow complex network topologies. So gone are the days of being able to say, let's just run a scan across this IP subnet and discover all the things and write a config from that discovery. Oftentimes, now people are using multi-AZ, multi-region cloud environments. And also anything that requires a hole to be made in a firewall in order to see a system. So whether that's SSH or some other protocol, if you have to make modifications to your firewall in order to allow the monitoring system to see it, then you're introducing delays, and you're also introducing potential security problems in the rapid modification of firewall logic. So polling is not a reliable discovery solution. So new systems, they need to be discovered in real time, and they need to provide push-based or event-based discovery and APIs. So push-based or event-based is critical. In an ideal world, our systems should register themselves into monitoring, and some monitoring tools do this with their agents. Other ones make it possible with discovery APIs that automation systems can interact with and publish events to. In the real world, these two things are complementary, so you should expect both push-based and event-based with discovery APIs. So automated monitoring is the next one. So new systems need to be monitored automatically, and the registration of these new systems is the easy part. Again, with the cloud, we get almost all infrastructures are distributed systems. So if you have a web server and a database, then you're running, I guess it's probably up for debate, but I would say if you have two systems, one's a web server, one's a database, then you're running a distributed system. And so conceptually, when you have these disparate systems, they fulfill specific roles. So we'd say like one is the database role, another one is the web role, for example. So conceptually, we're thinking about things more in terms of what the servers or the services do rather than the specific server itself. So you could have a simple architecture where you have one, let's say, a virtual machine that has the entire stack on the machine. But more and more we're seeing people that have more complex architectures where instead of putting everything on one node, obviously you have, so microservices is probably the biggest example of this. You have a lot of systems and one role per system. So to conceptually think about how we monitor the roles versus how we monitor the systems themselves, I think is important. And so some anti-patterns there are mapping configuration to individual systems is probably an anti-pattern versus mapping to roles. And then anything that requires remote access to a specific system it kind of falls in the same vein. So we feel like that is doing it backwards. So configuration should be mapped to roles, and monitoring should begin at the moment that a system comes online. It should just work. And so I think that it should be a given that any system these days will be able to monitor nodes as they come online. The more difficult part or the more interesting part from our perspective is what happens for the automated process when those systems go offline. So terminated systems should be automatically removed from monitoring. And figuring out how we do that and when we do that is where it gets a little bit more challenging. So again, with some cool things that we have from ephemeral infrastructure, we have cost incentives to say like we don't need, it's not the biggest shopping day of the year every single day. So when it is, we need 10,000 web servers. When it's not, maybe we only need 1,000 web servers. So there's a big incentive for folks to scale down their infrastructures when the load is not high. Or just when systems aren't being used at all. And in these cases, intentional acts that people take in the infrastructure look a lot like failures. You know, if you have 10,000 servers 1 minute and the next minute you only have 1,000 servers, that could be because somebody intentionally decommissioned 9,000 servers, or there's like a heating or serious power problem in your data center. So the anti-patterns correspondingly would be something like assuming that the lack of data is the cause, or is if you look at the lack of data and say, well, I know that there's way less monitoring information right now, but we also just decommissioned all those hosts, so everything's probably fine. And that would be an anti-pattern. Making assumptions about like the lack of network connectivity. So you might say, well, that server says it's offline, but the network over there is offline, so the server's probably offline because the network is offline. And also using monitoring as an absolute source of truth. So monitoring, we feel, should always accurately reflect the source of truth, but should never actually be the source of truth. And so for automated decommissioning, it should be invoked by the system that's being decommissioned. So for example, when the system knows it's going offline, it should say that it's going offline. It could be triggered by a provisioning system. So it could be triggered by the, like let's say a chef command to remove clients. It could be triggered by your cloud platform's APIs for when nodes are coming offline. It could be optionally verified by an external source of truth. So it may be Chef might know that a node is offline. Then you can verify that with AWS. And this really, we think, should be the most reliable function of a monitoring system. So knowing that when it's telling you your node is offline, your node is actually offline, we think you have to be able to rely on that information. If you can't, then you may as well just not monitor stuff at all, right? Like if it's paging you and telling you stuff that's just not true, or it's not telling you stuff that you need to know, then you may as well just turn it all off. All right. So we're going to do a little bit of audience participation. And I just want to kind of get a show of hands for what people's infrastructures look like at the moment, and it will kind of guide a little bit about the live demo that we do. So put your hands up if you've heard of Kubernetes. All right, sweet. And what about if you have Kubernetes on your roadmap? It's something that you're planning on using. Okay, cool. And anyone using Kubernetes in production right now? Awesome. All right, put your hands up if you know what the cloud is. So one thing that we should go over is put your hands up if you have just a general concept of like auto-scaling groups, elastic load balancers, those sort of concepts. Okay, cool. Perfect. And I'm assuming most of you are using or have used AWS or GCP. Yep. All right, that's the morning exercise is done now. All right, let me jump over to our demo. Okay. Perfect. Okay, so for anyone who's not familiar with it, this is Sensu's monitoring dashboard. So the setup that I have right now that I'm running is on my local machine, I have a VM, and that VM is running Sensu Enterprise, and it's also running one Sensu client. I also have on Google's Kubernetes engine some web servers, and both of those are represented in the single dashboard. So Sensu has this concept of a single pane of glass dashboard. You can have multiple disparate data centers that all have their own highly available Sensu instances in them, and then we provide a federated dashboard instance, so you can get visibility into all of the different ones. So in this case, we have Vagrant, which is my local one here, and the Kubernetes one, which is out on Google's cloud. Now, that this demo is in Kubernetes is not really that important. If Kubernetes isn't something that you're using at the moment, you can just imagine that Kubernetes is basically like a generic cloud provider. So some of the commands that I'm going to run would be the same for like auto scaling on Amazon, for example. It just provides an easy way to demonstrate that. So we have a website here. And it's a very boring website. All it says is that it is healthy. And in the ideal world, all websites remain in this state and nothing breaks. But for the purposes of this demo, we're probably going to make it break. And that is represented here on one of these backend clients. We can see that we're running a check against that. All we're doing is we're saying we want to run the HTTP check plugin against this. And this plugin will basically expect a 200 response. If it gets a non-200 response, then it will start complaining. So what we're going to do is I'm going to move this window across. Okay. So what we're going to do is Kubernetes has this notion of scaling up a deployment, but this is exactly the same as using an auto scale group, for example, on Amazon. So what we're going to do is the name of this website, because it's a pretty not a very smart website, is Dummy Backend. Right now we have two of those running. So if you have a look down the bottom here, this is the view of the current infrastructure. And you can see there's two instances of this backend. So what we're going to do is we're going to say, actually we want 5 instances of that backend. And we should see if my window is, if this is actually running the command. Give me one sec. Live demo. Okay, there we go. I was going to make this window a bit smaller. Okay, so then we can see it almost looked like I just pretended that happened by typing this. So we can see we added another 3 to there. So if we jump back straight across into Sensu's dashboard and we have a look at our clients, we can now see there's 5 of those backends. Each of those backends has come online and is already having its HTTP endpoint checked. So the thing I mentioned before about we're monitoring roles, what we do here is we say like all web servers, in this case, everything that has a subscription, or all backend servers need to run this check. Those servers came online, announced themselves as backend hosts, and so automatically started getting this check running. So that's like kind of cool, but I think this should be sort of a given for if you bring a node online, it's monitored. So what about when we scale down? So this might be an event where you have an auto-scaling group that went up to 5, and now we're going to say that auto-scaling group will go down to 1. So what happens here is we don't actually know which ones of those 5 are going to be taken out of production. Google is going to decide that for us. So only one of these 5 will remain at the end, and once that happens, I'm not sure why this watch command isn't running, then we will have only one, but we won't know which one that is. So there's no way to tell our monitoring tool at this point which one we're going to remove. We're having internet, yay Wi-Fi. Hang on one sec. Somebody said to me yesterday, if your talk is interesting, then you'll know because your Wi-Fi connection will work. Because if it's not interesting, then everyone will be on the Wi-Fi and it'll break the Wi-Fi. Uh-oh. Let's see. Come on. I had a slide prepared just for this, if this happened. Okay, so let's try that again. Come on. Okay, there we go. So now we can just see there's one backend there. And if we go back to our monitoring tool, we can see now there's only one. So there's no events here. We didn't get alerted. There was no notification sent. And what actually happened in this case was that it was a graceful shutdown. So Sensu is a message bus backed monitoring tool. So everything that happens is through Sensu, the client will publish messages onto the message bus. In this case, what happened was the Sensu client knew that the node was being asked to shut down. So just a normal graceful shutdown on the node. And as part of the service stopping, the last message that Sensu sent basically onto the queue was, I'm going away, don't worry about me anymore, don't monitor me, everything you know about me is gone, no events, just clear it out. And so at no point did Sensu think that these nodes were incorrectly down. So it knew that they were going away. So again, it's like a pretty standard instance. You want to like always make. It should be a given that like when you bring on a new node, you don't get notified about it. When you just take down a node gracefully, you don't get notified about it either. But there is a case where we do want to be notified. That case would be if the node itself had a problem. And so one example of that would be if the node. If the website itself crashed. So the one thing that this very basic backend does is it actually, if you send a post to it, and technically anyone can do this because there's no security, but it might make my demo even more difficult. Then what happens is if we jump through this load balance, so there should be one of these at some point that is unhealthy. I'm just going to keep getting the healthy ones. It's not really that important if this doesn't come up. Someone's getting paged because the website's down. Oh, right, yeah, that's right, because I was worried I was going to do it accidentally before the demo. Thanks. All right, there we go. Oh, yeah, and we got a response. Okay, so yeah, we have unhealthy, and so now Sensu is actually going to care about this once it runs the next check on that back end. There we go, critical 500. So in this case, we want to get paged. If that happens at 3 o'clock in the morning, you want to know that the website is no longer working at 3 o'clock in the morning. And so 3 events have happened, I guess. The first event was a new server got created. The second event was that a new server went away intentionally. So you don't want to get woken up at 3 o'clock in the morning for the intentional server being removed. And then the website crashed. You do want to get woken up in the morning if the website crashed. There's another instance where you do want to get woken up, which is where the server itself crashes completely before it has an opportunity to announce that it's going away. So that might be a catastrophic power failure or a server failure of some type that completely removes the client. And so what we do in that case is we would say, I guess we refer to that as a legitimate monitoring event, and that's definitely something that you need to trust the infrastructure to tell you about. And so I can't do the demo on Kubernetes, but basically if you have a server that gets completely obliterated before it has a chance to announce that it's going down, then Sensu is going to alert you, obviously, because it hasn't had that that graceful event that pops up and says, I'm going away. And it should do that, so you want to get woken up. But there's also another case where what happens if at 3 o'clock in the morning a server is taken out of production in an ungraceful way, but your cloud provider, for example, knows about it and replaces it with another instance. So if you were to query the API for your cloud provider to ask them whether that instance exists or not, then they'll say no, it doesn't exist because they've provisioned a new instance to replace it. And so that's actually a case where even if there's a catastrophic power failure at 3 o'clock in the morning, you don't want to be notified. And so what we do in that case is we reach out to, in that case it would be the EC2 API, and we say, so Sensu sees this server has gone away, and it'll say, I'm going to start alerting people, but before I start alerting people, I'm going to check the EC2 API, and I'm going to see the list of servers and the states of those servers that Amazon expects them to be in. And if the state of the server that I'm about to alert on is that it is down, then I'm not going to alert. So that's the other edge case where if you have an external source of truth that you can reconcile the monitoring against, then you're able to say, like, I only know this much about the infrastructure, but another system, it might be Chef or it might be Puppet or it might be EC2, knows other information. Let's reconcile the information together before we start triggering alerts. And then you, hopefully through those, will end up with a case where every alert that you get, theoretically in any event of a server being intentionally provisioned or intentionally or unintentionally decommissioned, will be an accurate alert, a legitimate monitoring event that that you want to be woken up for. So here's an exciting slide. Question time.
Thank you. Nice presentation. My question is, so it's really nice demonstration. Like if you add the containers or the pods, they are getting automatically monitored. But is it also possible to like say, only give me an alert if like less than, like if the number of available pods are like less than 80%, because that is in fact actually what you maybe are more interested in, not the specific container going down. Yeah, so that's one. It's probably another level from that, the concept of taking a server and then turning it into a role, and then you go from that role in the service sense to like a wider service. So you might say, the role of this server is, or of this instance is a web role, but the service it's providing is like the web service. And on the web service, we need 80% of nodes online, for example. So the way we do that in Sensu is a thing called named aggregates.
where you can define an aggregate pool, and then you can define the percentage of nodes in that pool that need to be okay in order for it to maintain the okay state.
Hi, thank you for the talk. You scaled up your health web service to a number of 5. Now imagine it auto-scales or you scale it up to 5,000. How fast will Sensu run the HTTP checks? Will it run them as fast as possible, all in parallel?
Yeah, so what happens is the topology is that the Sensu server's only job at that point is to publish a request to say all web servers need to run this HTTP check. So it publishes the one check request, whether there's one server or 10,000 servers. And then all of the client's jobs is to listen. They subscribe to that queue, and they each see the request. So there's no difference conceptually in the way that it's making that check request between 1 or 10,000.
Sorry, I had a very quick question. What do you call that feature where you reconcile the check against another external source? Is that a double check?
I think, so we just refer to them internally as integrations. So there's an EC2 integration, a Chef integration, a Puppet integration. And the job of an integration is to do the reconciliation. I don't know if there's a more specific term that we use in that event where we're saying like, check before you alert. Yeah, we could call it a double check. Yeah, nice. Coined a new term at OSMC.
Is that double check connected to notifications or for the individual status?
So what will actually happen is if we go out to, so let's say Sensu sees that a client has, an instance has gone offline, but it hasn't gracefully decommissioned itself, then the first thing that we would do ordinarily would be raise an alert. But when we go out to EC2 and we check the list of instances and we see the state of that instance is terminated, for example, then we delete the client. So monitoring doesn't care about it at all. And if there's any existing events for it, they'll go away. It's as if it never existed.
Okay. Any more questions?
So let's say you gracefully shut down a machine and afterwards I'm interested in performance data of that machine. Is there any concept to get it afterwards when it's deleted from monitoring?
So if you gracefully shut it down and then you want, the only way to get data from it again would be to bring it back online. Wait, hang on. If the machine's totally gone away and you're storing historical data, for example, in something like Graphite or OpenTSDB, then you would go and look for the historical data in that other place. One thing that we do, so with our integrations and like plugins, the open source plugins for Sensu, so you can send metrics data into all those systems. But if you have logging systems that you want to send that data to, we have a thing as well called the event stream, which basically everything that Sensu knows about, it just sends down a pipe in JSON format, so you can connect that to something like Elasticsearch. So we don't have a concept of historical data beyond the last 21 executions of a check in Sensu itself. And the way that we deal with that is to integrate with other tools that are way better at doing that. But if you brought the node back online again, and it announced itself as the same client and everything, we would just start monitoring it again. It would start collecting metrics again, and they'd go to the same place.
More hands?
Just a question of when you run in Kubernetes, do you run the sensor client as part of your cluster as a daemon set, or does it run outside?
So it's like a sidecar container in the same pod in this instance.
Okay, so you run it in every pod?
Yep.
Okay.
Yep.
Could you run it as a daemon set also for the sort of every instance of the nodes in the Kubernetes?
Yep. Yeah, there's a couple of different patterns. Or you could also run one and have the nodes themselves emit data out to that. Like, so you could run one somewhere else, for example. Yeah.
Okay, thank you.
So, thank you very much, Anthony.
Cool, thanks.